The first thing we do for problem 20 on the homework set is draw a free body diagram, which is part A. And I drew one ahead of time, and I just added in all the givens. So the bear is 700 newtons, the beam is 200 newtons, and the gift basket is 80 newtons, and the beam itself is 6 meters, which means that the radius would be 3 meters. Then the problem also says that the bear is 1 meter out. We also know that this is tension, this string right here, and it forms an angle of 60 degrees. And then there's an x and y component. And then we also know that there's going to be a hinge right here, and we'll go into that for part B. And I also established that the upwards direction would be positive and the right would be positive. So for part B, they want us to find the tension in the wire and the components of the reaction force at the hinge when the bear is at x equals 1 meter. So the first thing we should do is to find the sum of the torque. So we do the bear, and then we do the beam, and we do the gift basket, and we do tension. And then we're going to make our pivot point right here at the hinge, because we don't really know the forces that are happening over here. So the bear, it's going to be negative because it's going to have a tendency to move the beam in a clockwise direction, and that would be negative. So negative 700 newtons, and it's 1 meter out. And then it's sine of 90, which is 1, so I'm not going to write that. And then for the beam, it's 200 newtons, and it's 3 meters out. And again, sine of 90, which is 1. And then the gift basket is also negative. The gift basket is 80 newtons, and it's 6 meters out, so it's all the way over here. And there's also the tension, which is at sine of 60, and it's at 6 meters out. And then this is all equal to 0. And then once we plug these values into our calculator, we get tension equals 343 newtons. So hopefully you got that part, because I have to erase this and find room for the other part of part B. So they want us to find the components. So we're going to do sum of forces in the x direction. And we said that there was force of the hinge going towards the right. So that's going to be force of the hinge minus tension in the x direction. And this is all going to be equal to 0 since this whole diagram is in static equilibrium. So we find that the force of the hinge is equal to 171 newtons. And then in the y direction, we do friction, which is going upwards, and that's positive, minus, we're going to add all these up and then subtract it. So once we add up 700 plus 200 plus 80, we get 980 newtons. Plus tension in the y direction, so right here. So like that. And then we already solved for tension, and we're just going to plug that in here. So once we plug all that into our calculator, we get 683 newtons. For part C, the question asks, I have to refilm it now. For part C, the question says, if the wire can withstand a maximum tension of 900 newtons, what is the maximum distance the bear can walk before the wire breaks? So I'll just write out what they told us. So what we're going to do is we're going to sum up tension, torque again. And I'm going to write this out. So we're going to find the torques of the bear, the beam, the gift basket, and tension again. But this time we don't know the distance of the bear because we're trying to figure out how far it can go out. So again, it's negative 700 newtons times, we don't know how far it can go out, minus 200 newtons times 3 meters, and then minus 80 newtons from the gift basket, which is again 6 meters out, and we have 900 newtons times sine of 60 and 6 meters out. And this is all equal to 0. And then the only thing we're looking for here and trying to solve for is the distance. So once we plug this into our calculator and do some algebra, we find that the maximum distance that the bear can go out is going to be equal to 5.14 meters.